In today's talk, I'd like to talk about how to secure VMware Cloud on AWS using cloud-native services. For people who are not familiar with the offering, let's have a very quick overview. VMware Cloud on AWS is a cloud service delivered, configured, and supported by VMware. It's also sold by VMware. You can see VMware will deploy software-defined data center on top of AWS bare metal hardware. So this is not nested virtualization. It's running on physical hosts provided by AWS. And you can configure the hybrid link mode, which means you can log into vCenter to manage resources on-prem as well as VMware Cloud on AWS. The engineering team from both parties have done lots of work to create a high bandwidth, low latency link. So you can leverage cloud-native services to improve the security or bring your architecture to the next level. Let's talk, before we talk about the details, start with what it looks like from the structure perspective. So account, you will have VMware Cloud as DDC account. VMware manages this account on your behalf. So all the resources, for example, physical hosts as DDC components will be deployed into this account. And also you pay VMware for the resources. This is dedicated for each organization, so it's not shared. Another account is AWS custom-owned account. If you want to deploy the cloud-native services, will be deployed into this account. You pay this directly to AWS. How it works, how you connect these two environments together. So firstly, customer, you sign up VMware Cloud on AWS service, you got the credentials to log in into vmc.vmware.com. And then you will need to fill out which AWS account you want to connect to. And then the CloudFormation template, which is used by AWS as an approach to specify what resources will be deployed into AWS environment. In this template, it will define some resources. For example, IAM role. IAM is a mechanism for AWS to control security, who and has what access. Why you need this? So why when you want, and the VMware AWS want to grant access IAM role to VMware? Because we want to connect these two environments. For example, if you update your VMware SDDC, create a new logical network, VMware have that permission to update the routing table inside AWS account. So these two environments can talk to each other. Here, you have these two environments connected. And then what exactly happened under the hood is, because VMware has got the permission to provision some resources. For example, in this case, we'll provision an elastic network interface, ENI, into AWS account, and then present that elastic network interface directly back to the physical hosts. So this is a physical link dropped into your physical hosts. And this green box CGW is NSX running on top of that physical hardware as a gateway to control your customer workload traffic. So you can see these two environments already have the link connected, and routing table know where it will send the traffic, which interface it will direct traffic to. In the event of failure of that CGW or physical host, VMware will start another CGW on the alternative host, in this case host 2, because VMware have permission to update the routing table, so it will change automatically for you. So this will be a very transparent experience for end users. Now we talk about structure. Let's get into the security, how you're going to leverage cloud-native service to enhance security. For example, you have your public-facing applications up running on VMware Cloud on AWS. That's a box on the right-hand side. And we leverage ALB, Application Load Balancer, as a front end, which is a managed load balancer provided by AWS. And you use that high bandwidth link we mentioned earlier and go through the elastic network interface to connect these two environments. It got a very efficient connection and low latency. Why it helps security? Because it's not only a load balance service, it also validates the protocol before it is sent to the backend VMs. Even furthermore, we can continue using other cloud-native services. For example, in the box in the middle, you can see the WAF. That's a web application firewall. So this one will provide an application layer firewall to prevent application layer DDoS attack. For example, SQL injection. CloudFront will validate the traffic before it's sent back to the backend resources. Shield will provide real-time monitoring and remediation for DDoS attack. And Route 53 have built-in feature to prevent DNS type of attack. Let's put everything together and take a look at the big picture. If we take a step back and start with where we start from, this is multi-tier applications already deployed into VMware Cloud on AWS. 3-tier, front end, middle tier as application, and back end, you use a shared server to host the data set. What if you want to scale out your application because you have traffic increased? What you would do is you need to make a decision where you're going to store your large data set. Here, we replaced the file server using S3. How are you going to leverage S3 as your file server? Because we deployed a storage gateway as a proxy for you to just mount S3 bucket, exactly the same experience as NFS server. So you have the shared data set sitting on S3 bucket, provide that high durability and availability. As mentioned, you can leverage managed load balancer, ALB, as a front end to provide the secure protection, and other cloud-native services, Route 53, CloudFront, Shield, and the web application firewall. So here, we already use cloud-native services to protect your front end. What about your compliance? How do you know someone make a change? Do you have a mechanism to keep track of your compliance? Here we will introduce AWS System Manager, which is a centralized place you can manage your VMs and also control your compliance situation. Let's look at how it works. For example, we call it compliance as code. You pre-configure some policy beforehand. I use a very simple example. This particular package needs to be installed inside these VMs. You can come up with a more complex policy. So here, next step, you need to associate these VMs with AWS System Manager. What that means, the service will provision an agent into your VMs, and then you set up a routine to scan these VMs on a regular basis to compare the current settings is compliant with your policy. Let's say if you have a configuration drift, someone remove this package or change some configuration, doesn't comply with your policy, you'll see that dashboard, you have a red bar come up to show you need to take some remediation immediately. So you have central place to detect and also have dashboard and also remediate that risks. So that's the end of the talk. If you want to try out VMware Cloud on AWS, you can simply sign up, and we provide a trial for single node for 30 days. You can easily enhance your security with cloud native services. Thank you.